Okay, sixth period, Algebra 1. This is direct and inverse variation. Continued. We looked at this last class, but it's a good review of what we learned. And if you didn't get it that class, maybe you'll get it today. Just do your best, stay focused, and ask questions when you need to. But follow along with this video. You can stop it whenever you need to, pause it, rewind. Work at your own pace, but just work hard and do your best, and once you finish these notes, you'll work on some practice problems. Okay, but direct and inverse variation, we're going to start with a review of direct variation. Direct variation equation is y equals k times x. K is the constant of variation, okay? If we were solving the equation for k, we would want to get k by itself. So that means you're going to divide by x. When you do that, you get k equals y divided by x. What does a graph of a direct variation look like? Well, it goes through the origin, which is the point 0, 0. Right there. You look down at these, the x and y axis, it's right there in the middle. That's the point 0, 0. Direct variation is a straight line that crosses through the origin. So it might look like that, a straight line crossing through the origin. How do you know that this table represents a direct variation? What you can do is divide each y by x. If you get the same number each time, it's a direct variation. So here's what we mean by that. If you take this 6 and this 5, you do 6 divided by 5, you get 1.2. 12 divided by 10, that gives us 1.2. 18 divided by 15, what do you get? 1.2. 24 divided by 20, what do you think it is? Is it 1.2? Yep. And last but not least, let's try 30 divided by 25. You get 1.2. All right, so you're getting the same number every time you do y divided by x. That means it's a direct variation. So think D for divide. And direct variation begins with D. All right? So that value that you just got is your k value. So the k value in this direct variation is equal to 1.2. For inverse variation, y is equal to k divided by x. K is still called the constant of variation. But this time, y is equal to k divided by x. We would read this as y varies directly as x. To solve the equation for k, this time we're going to multiply both sides by x to get k by itself. So that cancels out, and then since we did it on the right side, we're going to multiply x times y, and that's what's equal to k. So in an inverse variation, k is equal to x times y. You can cross out what I crossed there, but I'm just going to draw for you what the graph of an inverse variation might look like. So if you're ever asked which graph represents an inverse variation, you're going to be looking for one that looks like this. So how would you know if a table represents an inverse variation? This time you're going to multiply x times y, and if you get the same number each time, then it's an inverse variation. So we'll do x times y. We'll do 1 times 16, which equals 16. 2 times 8 equals 16. How about 4 times 4? Yep, that's 16. 8 times 2, 16. 16 times 1, 74. No, I'm just kidding. It's 16. So we got 16 each time, right? See? 16, 16, 16, 16, 16. Okay, we got the same number each time we multiplied, so that means it's an inverse variation. And our k value is equal to 16. All right? So to determine if it's direct, divide. To determine if it's inverse, multiply. On a word problem, often the problem will tell you right away if it's a direct variation or an inverse variation. The word vary indicates that it's a variation problem, and then it says directly. So it's a direct variation. This says x and y vary directly. When x is 2, y is 6. And then it's asking us to find an equation that relates x and y. So first of all, step 1 says, is the variation direct or inverse? We said it's direct because it says x and y vary directly. Then it says, write the direct variation model. We learned that that is y equals k times, that's a k, sorry. Again, y equals k times x. Now it says substitute 2 in for x and 6 in for y. So now we have 6 equals k times 2. Then it says, for step 3, it says simplify to find k. So since k and 2 are multiplying each other, to get k by itself, we're going to divide by 2 on both sides. So that cancels out. 6 divided by 2 is 3. So k equals 3. So now that we know what k is, we can write the direct variation equation. Y is going to go back to being y, x is going to go back to being x, but now k is 3. So instead of y equals k times x, we're going to have y equals 3 times x. Which we can now use to find more points in this direct variation. Also, if you go to y equals on your calculator and then go to the table, you can get some points for the line y equals 3x. You're going to see that the point 0, 0 is there. Remember, direct variation always goes through the origin. You'll also see point 1, 3. Oops, there we go. And we'll see the point 2, 6. One, 2, 3, 4, 5, 6. There we go. And then you can draw. Make sure you get right on the corner there. And you can see it's going to be a straight line going right through the origin. So, our direction said create a graph showing the equation from problem 1, and here it is. We put the origin 0, 0. The other 2 points that we got were 1, 3 and 2, 6. Again, you can find those in your table, or you can plug in values for x to find y. Raise your hand if you have any questions. Now, problem number 2 says x and y vary inversely. When x is 5, y is 10. Find an equation that relates x and y. So step 1 says, is the variation direct or inverse? Well, I read the word inverse, so I'm going to say it's an inverse variation. The inverse variation model is, that we learned, y equals k divided by x. We're going to use that to help us out. Step 2 says substitute 5 in for x and 10 in for y. So now we have 10 equals k divided by 5. Simplify to find k. Multiply both sides by 5, and you get k equals 50. Then plug k in to write the inverse variation. So our equation this time is going to be y equals 50 over x. And k goes on top, so 50 over x, or 50 divided by x. All right, for direct variation word problems, like you're not always going to have the variables x and y, because you'll be dealing with like more realistic stuff. So you just want to remember to set everything equal to the first variable that you read. Remember, variables are just the letters that represent unknowns. So, like when you're reading problem number 3, it says the number of days d. Right then and there, we know that the equation is going to be set equal to d. So we'll come back to that later. And let's just read the problem. The number of days d it takes students to set up for the school play varies inversely with the number of students x. The school play was set up in 6 days by 18 workers. Write an equation that represents this situation. So first of all, it's an inverse variation. But instead of y equals k divided by x, we're going to say d equals k divided by s. So d equals k divided by s. Again, we read d first, so that's what it was set equal to. We also said it was an inverse variation, so we'll write inverse. Now we're going to substitute in 6 for d, so we're going to say 6 equals k divided by 18. Now to simplify to find k, we're going to multiply both sides by 18. And that will get k by itself. After simplifying, hopefully you got k equals 108. 18 times 6 is 108. We're going to plug in k to write the inverse variation, so we're going to say d equals 108 divided by s. And that equation can help us solve other problems. But that's how you set up the equation. So you guys should be able to try these next problems out on your own, and we'll help you out with them. But we're just setting up equations by reading the word problem. So problem number 4, I'll do this one also, and then you guys can give it a shot. Sometimes you also have to find the equation and then find more information. But we'll let you know when that happens, and you get good at it. So for problem number 4, it says, in a factory, the profit P varies directly with the inventory I. So we're going to say, this is a direct, and we're going to say P equals K times I. Well, if we want to find K, then that would mean K is equal to P divided by I, right? So if K times I equals P, if we want to get, this is another way to draw an I, sorry about that. But we would divide both sides by I, and K would be equal to P divided by I. Alright, so K equals P divided by I. Sorry about that. Again, that says K equals P divided by I. And earlier in the word problem, or later in the word problem, it says that P equals 100 when I equals 20, and we want to find an equation to write this relationship. Well, we would put 100 in for P and 20 in for I. Do the division, K is equal to 5, right? 100 divided by 20 is 5. And your equation would be P equals 5 times I. That's it for now. Have a great day. Keep working hard.